Problem 3-46. Decide whether each of the following pairs of expressions or equations are equivalent. If they are, show how you can be sure. If they are not, justify your reasoning completely. So looking here at A, we have the product here of AB, and we're squaring it, and we're comparing that to A squared B squared. So if we look at the product AB that's being squared, remember, this is saying A times B times itself. If you think about A times B times itself again, we can use our associative and commutative properties to rewrite these. So let's take it and use our commutative property to rewrite the order here, because all we're doing right now is multiplying. So we have A times B times B. And another way to write A times A would be A squared. And another way to write B times B would be B squared. And since we now have the same expression as we started with on the right side, the A squared B squared, it's safe to say that A squared B squared is equivalent here to A squared B squared. So our original equation, the product of AB squared, should also then be equivalent to A squared B squared. So this one is equivalent. Smiley. All right, B. We have 3x minus 4y equals 12, and we have the equation y equals 3/4 x minus 3. Well, our equation on the right is already set to the form where y has been isolated. So we have y equals, let's go ahead and do the same thing to our other equation. Let's get rid of our 3x first here, or you could take it and you could add your 4y, whatever you prefer to do. I'm going to go ahead here and subtract my 3x from each side. So I'm going to end up with, remember this negative sign, or this minus, belongs to the 4y here, so that needs to come down with it. I have negative 4y is equal to negative 3x plus 12. And then I can go ahead and isolate my y by dividing by negative 4 on each side here. And I'm just going to go ahead and divide each term on the right side by negative 4. So I'll end up with a positive y equals a negative 3 divided by negative 4. Well, obviously a negative divided by negative is a positive, so we're going to end up with 3/4 x, and then 12 divided by negative 4 would be a negative 3. Since that is exactly the same as the equation that we started with on the right here, it's going to be safe to say that these two expressions are going to be equivalent here. Now, if you want to take values and plug them in for x and y, you should end up with the same values as, or between the two equations for your outputs. So we can go ahead and state that these two equations are equivalent. Looking at C. C starts with the equation y equals 2 times the quantity of x minus 1, and then we're adding 3. We're trying to justify whether or not this is equivalent to y equals 2x plus 1. So let's go ahead and try to simplify our equation on the left. We have y equals 2 times x would be 2x. Remember, we've got to distribute it through. And then 2 times negative 1 would be minus 2 plus 3. So we have y equals 2x minus 2 plus 3. Well, if we combine our like terms there, negative 2 plus 3 is going to be a positive 1. And we get y equals 2x plus 1. Once again, this is the exact same as our equation that is on the right. So we can say that these two are going to be equivalent. Letter D, we have the quantity of the sum of a plus b, and it's being squared. We're trying to say, is this going to be equivalent to the expression a squared plus b squared? This is one that there's often mistakes made when people don't take the time to think through what this actually means. we're taking the quantity of a plus b times the quantity of a plus b. So if you think about it there, and I'll go ahead and draw out my generic rectangle here. We're going to be multiplying an a plus b times an a plus b. So let's just go ahead and find the areas of each of our individual rectangles here. A times a is going to give us the area of a squared. A times b is going to give us the area of ab. A times b is going to give us another ab. And then b times b is going to give us b squared. When we take this and we combine our like terms and put it together, we should end up with a squared. We have plus AB, which is the same thing as saying plus 2AB plus B squared. Now, is that going to be the same thing as A squared plus B squared? No, it's not. And we can justify this by taking it here and plugging in values for A and B if we'd like to show it there. Make sure you put in a different value for A. When A and B, don't put in the same value for each. And go through and simplify it down there, and you'll see that you will have a different value coming from this expression than you would from this expression on the right here. Please be careful though, using zeros and ones. Sometimes they look like they're going to be equivalent, but they actually aren't. Moving on here to parts E and F. Part E, we have x to the 6th power divided by x squared, and we're comparing that to x to the 3rd power. So just remember x to the 6th. If you can't remember your exponent rules, just think about what this means. X to the 6th is like saying x is a factor 6 times. You're dividing it by x squared, which means x is a factor twice down here. When we have a common factor divided by itself there, what is anything divided by itself going to be? It's going to be 1. So x divided by x is going to be 1. X divided by x here is also going to be 1. So right now we're looking at 1 times 1. Let's actually just write those out here. This would be like 1 and 1 here. 1 times x times x times x times x is going to give us x to the 4th. 1 times 1 is just going to give us 1. So we end up with x to the 4th over 1. Well, if we compare that to x to the 3rd, is that the exact same thing? No, it's not. So it's safe to say here that these ones are not equivalent. And I forgot to write my answer for D. But that one was not equivalent either. Last one, part F. We're going to compare the equation y equals 3 times the quantity of x minus 5 plus 2, and we have y equals 2x minus 8. Let's go ahead and simplify the equation on the left here by distributing our 3 through the expression x minus 5. We're going to have y equals 3 times x would be 3x. 3 times negative 5, or if we take away 5 3 times, we're going to be taking away a total of 15, and then we're adding 2 to it. To simplify it the rest of the way, we're just combining our like terms. You're taking away 15 and then adding 2. So that would be y equals 3x minus 13. So we look on our right side, we have y equals 2x minus 8. These two equations will not give us the same answers here. And if we took values and plugged them in, let's say I plugged in 1 for x here. 3 times 1 minus 13. We would get 3 minus 13, which is negative 10. So it's safe to say that the point 1, negative 10 is a solution to this equation. Now if I take it here and I try to plug in that same point, if these are equivalent, there's a chance that we would get the same output here. Let's see what happens. If I plug in negative 10 and 1, it should make it true if they are equivalent. Negative 10 should equal 2 times 1 minus 8. 2 times 1 is 2, minus 8. Well, 2 minus 8 is going to give us negative 6. That does not equal negative 10. So we know that these two equations are not equivalent. Go ahead and try plugging in another set of values if you choose, so that you get a better understanding of the equivalence between these two equations. If you have more questions, please make sure you ask your teacher.